So let us take few more organization and architecture questions, electronics. So what is pipelining? What do you mean by pipelining? Pipelining may be visualized as a collection of segments called pipe or pipe stages through which binary information flows. And each segment performs partial processing as dictated by the task. So the result obtained in each segment is transferred to the next segment in the pipeline, and the final result is obtained after the data passes through all the segments. So this is pipelining. That is, you can just visualize it as a collection of segments. We can call them as pipes or stages, which is actually data which is flowing through them. But each segment, these segment, they perform the actually we have a process, so they perform partial process. A task advise them, and they perform the partial process, and then these process the partial, they are coagulated, and then the final result is obtained. Explain the latency and throughput. I'll give you a real time example, or real life example rather. See, latency means if I speak and you listen after say 10 minutes. So the latency would be 10 minutes. Okay. So the time lag, because you are in front of me, when I speak, you listen. But if I speak and you listen after a certain time, that is a latency. Though computer architecture and organization in this term, this will be different, but I'm just giving you how you can relate with the latency. And the throughput will be like this. Say in a manufacturing say company, 100 products or 100 objects are made per say minute or per second. Okay, 100 of product per second. So this 100 is the throughput, right? Now let us understand in terms of our present subject. So latency, each instruction takes certain amount of time to complete. This is called as latency. So this is the time difference when an instruction is issued and when it is completed. So issual and completion, the difference of these two times is nothing but the latency. Then comes the throughput. What is this throughput? The number of instructions completed in a given time is called throughput. Number of instructions which are completed. What are the major characteristics of pipeline? Pipelining cannot be implemented in a single task, as it works by splitting multiple tasks into number of subtasks. So you have task, you make it multiple tasks, you split them and operate on them simultaneously. So these subtasks, you operate on them simultaneously. This is what pipelining is all about. The speed up and the efficiency is achieved by using the pipelining. It depends on the number of the pipes or pipe stages and the number of available tasks that can be subdivided. Next comes the what is pipe stage. Each step in a pipeline is called a pipe stage. So what is instruction pipeline? The type of pipeline which works by partitioning the instruction execution. What are the various stages in pipeline execution? Instruction fetch, decode, operand fetch, operation execution, write back. Define pipeline hazards. The pipeline architectures work smoothly as long as it is able to take up new tasks in every machine cycle. In practice, there are situations when the next instruction can be executed in the following machine cycle. So these events are called pipeline hazards. State different types of hazards that can occur in pipeline. So there are various hazards like data hazards, instruction hazards, structure hazards. What are data hazards? Data hazard is a condition in which either the source or the destination operand of an instruction, they are not available, they are not present, or they are not ready at the time of the time which is expected in the pipeline. So as a result, some operation has to be delayed and the pipeline actually stalls. What are instruction hazards? The pipeline may be stalled because of a delay in the availability of an instruction. So for example, this may be a result of missed cache requiring the instruction to be fetched from the main memory. Such hazards are called as instruction hazards or control hazards. Structure hazards. The structure hazard is a situation when two instructions require the use of given hardware resources at the same time. two instruction hardware at the same time. So the most common case in which this hazard may arise is the memory access. What is superscalar processor? Superscalar processor. Superscalar processor. It actually exploits or employs or uses parallelism that has multiple execution unit, each of which is pipeline, and it constitutes independent instruction pipeline. So the processor has a processor unit, a parallel unit designed to fetch and decode several instructions concurrently, which is issued to pipeline units that execute several instructions at the same time. This is superscalar processor. What do you mean by out of order execution? Is it desirable? Out of order execution. In a pipeline processor with several instructions, when you have concurrent process, it is possible for instruction to finish out of sequence. So one instruction finishes before another, which is issued earlier. As far as the main computation is concerned, no hazards will happen, but if an interrupts occur, it may create certain problem. Again, hazards we have seen. The hazard is also called as a hurdle. So the situation that prevents the next instruction in the instruction stream from executing during its designated clock cycle is known as hazard. Stall is introduced by hazard. List out various branching technique used in microprogram control unit. Bit ORing using control variable and wide branch addressing is also there. What is microprogramming and microprogram control unit? Microprogramming is a method of control unit design in which control unit selection and sequencing information are stored in ROMs and RAMs, called control store or control memory. Microprogram control unit is a general approach used for implementation of this control unit. Here a program which is similar to machine language program generates control signals. What is meant by hardwired control? The one contains control units that use fixed logic circuit to interpret instructions and generate control signals from them. The fixed logic circuit block includes the combinational circuit that generates the required control outputs for decoding and encoding functions. So what is the necessity of grouping signals? First is it is used to reduce the number of bits in the micro instruction, grouping signals. And it is used to overcome the drawback of assigning individual bits to each control signal, results in long micro instructions because the number of the required signals is usually large. Moreover, only a few bits are used in any given instruction. List the techniques used for grouping the control signals. You have vertical organization, horizontal organization. So what is job sequencing now? It is a process of scheduling tasks that are awaiting initiation in order to avoid collision and achieving high throughput. This is job sequencing. Write control signals for storing a word in memory. R1 out, MAR memory register, address register in, R2 out, then this MDR, then you have write MDR, then you can write. So these are these control signals for storing a word in memory. What are the problems faced in instruction pipeline? First is resources conflicts, data dependency, of course, then branch difficulties. What is register renaming? See, if a temporary register assumes the role of the permanent register whose data it is holding and is given the same name, this is called as a register renaming. How data hazard can be prevented in pipelining? Data hazard in the instruction pipelining can be prevented by the operand forwarding, and there are software approaches also. Explain the various approaches used to deal with the conditional pipelining. A conditional branch instruction introduces the added hazard which are caused by the dependency of branch condition on result of a preceding instruction. And branching instruction represent about 20% of the dynamic interaction counts of the most programs. And the dynamic count is the number of instruction execution taken into account that the same program execution is executed many times because of loops. So these branching junctions can be handled in these ways: delayed branching, branch prediction, and dynamic branch prediction. So these are a few more questions on our organization architecture. We'll be taking more shortly. Thank you so much.